Three very large square planes of charge are arranged as shown. From left to right, the planes have charge densities per unit area of negative 0.5 microcoulombs per meter squared, positive 0.1 microcoulombs per meter squared, and negative 0.35 microcoulombs per meter squared. Find the total electric field, direction, and magnitude at the points A, B, C, and D. Assume the plates are much larger than the distance AD. Because the plates are much larger than distance AD, the distance between the point and the plane is insignificant. That is why we are given the equation electric field of the plane is equal to sigma, the charge density, divided by 2 epsilon naught, where epsilon naught is a constant, equal to 8.85 times 10 to the negative 12 coulombs squared per Newton meter squared. So first, we take one charge at a time. One point at a time. Let's take point A. Point A is being pulled to the right by planes 1 and 3 because they are negatively charged and attract point A. A is being repelled by plane 2 because of its positive charge. For this reason, we take our equation and we make planes 1 and 3 positive, making the right the positive direction, and plane 2 negative because of the negative direction. So positive plus positive, plane 2 is negative. Plane 1 minus plane 2 plus plane 3. We carry those down, minus and plus, and we carry those down, minus and plus. These are our charge densities, 0.5 from plane 1, 0.1 from plane 2, and 0.35 for plane 3. And we multiply all of these by 10 to the negative 6 because they are microcoulombs, and to convert them to coulombs, we have to multiply them by that. Then we divide all of that by 2 times epsilon naught. And this gives us the value 4.2 times 10 to the 4th newtons per coulomb. And this is to the right. Now we do the same thing for B. So we are going to subtract planes 1 and 2 and add plane 3. So subtract planes 1 and 2 and add plane 3. And this gives us 1.4 times 10 to the 4th newtons per coulomb. But this is to the left. We do the same thing for C. This time, we are subtracting plane 1, but adding planes 2 and 3. So we're adding planes 2 and 3. And this gives us the answer 2.8 times 10 to the 4th newtons per coulomb. And this is also in the direction to the left. Now one more, point D. We subtract planes 1 and 3 and add plane 2. So subtract 1 and 3 and add plane 2. Subtract 1 and 3 and add plane 2. And this gives us the answer 4.2 times 10 to the 4th newtons per coulomb to the left. Oh, correction. Point C actually gives us the answer 2.8 times 10 to the 3 newtons per coulombs to the left. Correction. Thank you.